Hi, my name is Kelly Scott Sims, and this is my Project 8 using FreeRTOS to transmit 3-axis IMU data. So the project actually required having this hooked up to the drone and shown real time while flying, but I actually ended up getting a bad IMU sensor. I even emailed the professor about it, and he had to express deliver a new one for me. But unfortunately, I live in Switzerland where things aren't happening overnight, so the new sensor isn't going to arrive until after the due date of this project. So I didn't want to hook up a faulty sensor to the drone and then just have to cut all the wires and everything off again because it's a bad sensor. So at a minimum, I wanted to at least show the setup of everything and then walk through the code to show how both using FreeRTOS on the Arduino to transmitting to the Raspberry Pi to transmitting real-time data wirelessly to a remote host to collect the data. So yeah, I'm going to walk through the code and at least demonstrate how all my code and everything is set up, even though I can't do it on a real drone until I get my new sensor. So where you can see over here right now, I have the IMU just hooked up on a breadboard. I will solder it onto an actual board to put it onto the drone to make it a little bit easier. But it's just using I2C to my Arduino R4 here. I'd have it plugged directly into my computer right now. And then this is my Raspberry Pi 5 that I'll be hooking into. That's just the power cable for the Pi 5 here. So if we look at the code that I have here using FreeRTOS, I'll just kind of walk you through it. So I'm instantiating an IMU sensor object here to interact with. And then this is the actual struct data that I'll queue up using, again, FreeRTOS. That I have two tasks, and I'll go through each task. But one task is to sample data from the IMU and then persist the data in the struct and then queue this data up so that another task can get the data from the queue and transmit it. And we'll kind of go through that. So I'm instantiating a queue here, and then these are just task handles. I don't actually use them in this code, but it's just required in FreeRTOS to give a task handle. So just instantiating what's necessary. My queue length will be 10. I didn't actually play around with this. I don't know why I started off with 10, but everything works fine with 10. And here's the first task, and this is the task that will actually sample from the IMU here. Again, because I had issues with my sensor, I did everything to troubleshoot it. You probably saw it in the email that I sent of every different thing that I tried, but I tried adding different delays to make sure I wasn't getting bus congestion. I put in some checks in here that just, yeah, it was a bad sensor, but I left some of the delays in here. They're probably not needed, but that's why they're in here. So yeah, in the task we just have this infinite loop here that after some amount of delay, it will actually get some sensor data from the IMU, and then it'll get the data packet that I declared up here, and we will queue up the data, getting the X orientation, Y orientation, Z orientation, and then we put that on the queue with the data, and then we add yet another little bit of delay here before we go back through and sample again. So that's the sampling task using FreeRTOS, and then here is the transmitting task. So I'm simply just transmitting across serial. The Arduino will be plugged in via USB into the Raspberry Pi, and it'll just read from serial. So here we just have an infinite loop here that we will read off the queue if there's data. And then from the queue, we are printing it as CSV data. So the X, comma Y, comma Z data, and that's being sent across serial. And we'll just infinitely do that. And yeah, that's the two tasks to collect and receive. So then we go into our setup here. Again, more troubleshooting stuff here. I was making sure it wasn't an issue that because I'm using a newer, more powerful Arduino, that it just wasn't waking up and doing things quicker than the IMU could handle. So I was adding delays. I tried everything to troubleshoot why this thing wasn't working. But either way, this is just setting up, initializing the IMU unit. Here I'm switching it to the 9 degrees of freedom mode. Here's all the different system status checks I was doing to figure out what was going on with it. This isn't all necessary stuff, but this was all sanity checks to see that basically the IMU was working initially, and then it fails out as if something's going wrong internally. Maybe I'll be able to demonstrate it for you. But yeah, this is all just system health checks at boot up. Yeah. And then here's actually creating the queue. So I initialized or declared it. Here's me actually initializing it with my queue length of 10. And then here's the actual queuing up the tasks. So using FreeRTOS, the X task create, adding a task for sampling, calling it sample IMU. I'm giving it a stack size of 600. I'm not passing in any parameters to it, and I'm setting its priority as 2, so I'm setting it as a higher priority than the transmit one here. And then here's the task handle that I said it wasn't using but had to instantiate. And then the same process again, but for the transmit task. It's again the same stack size, but its priority is a little bit lower here. And yeah, the last thing we do in the setup is start the task scheduler here. And because we're using FreeRTOS, nothing actually goes in the loop here. It's all handled by the tasks in FreeRTOS. So if we actually go and look at our serial monitor here, we'll see what it's doing. Maybe the IMU will start doing data here. Yeah, okay, so it was sending some data here. But yeah, okay. So you see it's doing all zeros now again, but I'm getting some. But the moment that I go and move this thing, yeah, you see it was doing data and then it stopped. So if I reset this again, we clear output here, switching, yeah. So it starts off sending data, and it still is. But for whatever reason, whenever I go to move it, yeah, it just out. I tried different calibrations. I would even print the calibration data. It just wouldn't go. So, yeah, that was my problem there. So that's transmitting, or that's just showing the code on FreeRTOS, how that's being transmitted via serial. So now let's go to the Raspberry Pi and see what's happening there. So I need to actually connect into it first. So there, and then put in my password. Okay, so we're in the Pi. We'll open up the folder. I have the folder here with the code. I have to put in the password again. Alright, and then here is the code, and I'm actually going to switch this over now to the Pi. We don't need to see it on the computer anymore. So when I plug this into the Pi now, the Pi will be powering the Arduino, and we can read from serial as well. So what's happening here is on the Pi, like I said, we're going to read from serial, and then we're also setting up a TCP server so a remote host can get the data. And we're just saying that we're accepting connections on any port on any IP here as the remote server here. And then I have a function here for generating dummy data. This was just a way for me to test on the remote client that connects to the server is receiving data and plots and renders it correctly. Since I was getting all zeros, I needed to generate fake data to make sure my plots was working, and we'll see the plots in a second. So that's not super important, but here is the function that actually reads from serial. And so all it's doing is getting from our serial port, which is just all these things here, the variables for setting up here, so the baud rate and the serial port. So the moment that I plugged this into the USB, it added a serial connection here, and that's where we're going to read from the Arduino. Where are we? We are here. So yeah, we're getting from the serial. We're just printing that we're connected to it, and then we have an infinite loop here. And actually, let me make this a little bit bigger so you can see. So yeah, we have an infinite loop here that we're just reading off the serial. We're persisting this as our latest data. And then yeah, in that infinite loop, we're just reading from serial, persist as latest data. And this is going to be a task that runs in a background thread. And then for our actual main server here, we're setting up a TCP socket server, WebSocket. And this socket is listening on its host and port that we defined at the top, and then it blocks until something connects to it. And once something connects to it, then we go into our infinite loop here, where we are making a copy of the latest data that's running in the being created in the background thread by this serial reader here. And then yeah, we just send that across to whoever connected to us, and that just runs infinitely. So to see what that looks like, let's not do dummy data right now. Let's actually do the IMU. So this is set up right now for reading the IMU data coming across serial. And then over here on the on my actual desktop that this is being run on here, this is the script to be a remote client, where it's going to connect to my Raspberry Pi's IP address on the same port that we set it up for, and then we have a background thread function here that is going to be pulling data off of the TCP connection, and then parsing the CSV data that's being sent across. So we're connecting to the Pi, and then we have an infinite loop here that we receive a chunk of data off of the TCP connection, and then we check and make sure that it's CSV data. We try to parse it in three parts because remember we're sending it across from the actual Arduino. If you remember, we're sending it as our X data, comma Y data, comma Z data. So expecting three parts here being sent across from the Raspberry Pi server. And that's all that's doing. It's persisting it in a global variable data X, data Y, data Z. And then we're just setting up some plots here that will basically plot the X, Y, and Z data. And then we set up a background thread method here that will just continually update the plots that we've created here with the X, Y, and Z data. So we start a thread for the data listener, and then we have a matplotlib animation function that takes this update plot function here, and then at 20 milliseconds or 50 frames per second, it will constantly update the plot. So if we come over here and start the server here, oops, why is it still set on dummy? Oh, because I didn't save it. So let's not run on dummy mode. We want to on read serial, yes, and we're saved. Okay, so now it shouldn't be dummy mode. Okay, so we're listening here, and then if we go to my remote host, Python remote client. Okay, so this is remote client connecting in, and boom, we are getting data. Let me make this plot a little bit bigger here, if I can. Yeah, there we go. And so yeah, we can see here we have our X, Y, and Z. The data that's coming across from the actual IMU that's being received by the Raspberry Pi server and then being transmitted across. Let me go back a little, make it a little bit smaller so you can see. But yeah, all the data being transmitted across, you see it's matching. And then just for sanity check to show that my IMU is still busted, you should see that once I start moving this again, yeah, it just all goes to zero. So still no bueno. So if we quit that and quit that, and we switch it over to the dummy data so I don't have to worry about it going all to zeros here. So now just generating dummy data here on the server. And this is again just to demonstrate how we're going from the Raspberry Pi, which will be attached to the drone, transmitting to a remote client connected in. So if we run that again, and you can see, yeah, running in dummy mode, no Arduino required. I'm just generating fake data. And if we run the client again, and now I don't have to worry about my IMU going bad, and I can still show you the graphs and the plots here. So yeah, you can see how we're going to plot this in real time on the actual drone and be able to get the data. But yeah, this is my project showing how I am capturing data from a busted IMU using FreeRTOS on the Arduino and passing through the Raspberry Pi. Thank you.